We're asked to find the area of this trapezium inside a three-dimensional cube. So first up, the area of a trapezium is actually a half times a plus b times h, where my trapezium, here are my parallel sides, a and b, and my perpendicular height is h. I'm going to state that without proof, that's worth knowing. So let's try and work out these quantities. So this is going to be my b. And I can actually construct a right angled triangle here. There's the right angle. And I know that the cube has lengths 2 root 2. So that's 2 root 2 and that's 2 root 2. So if I want the base, it's going to be 2 root 2 squared plus 2 root 2 squared, or 2 lots of 2 times 2, 2 times root 2 squared. That's going to be my base, which becomes 2 times 2 squared times 2 square rooted, and I'm actually going to get 4. Right, the base is sorted. Okay, now we've got the top. Can also draw a right angled triangle like that, and because G and H are the midpoints, this length is root 2 and this length is root 2. And similar lines, we've got the top. It's going to be root 2 squared plus root 2 squared, but that is the same as 2 times root 2 squared, square rooted. So that gives me 2 times 2 rooted, or 2. Yeah, the only thing left to find is the perpendicular heights, and I did it using the following method. I decided to go straight for the middle and connect it to the middle down here. And actually, I'm going to draw it in purple like that. And then I'm trying to work out that length. So I've got to use the height of the cube like this, bring it down. And that is actually going to be a right angle because I'm bringing a line straight vertically down and I'm going along the base. I could maybe do that slightly better. So let me try it one more time. Okay, I'm all right with that. That's my right angle. I'm going to draw the triangle in profile. So the top is there, the bottom is there with the right angle. This is where it's connecting with the 4. So I know the height of the triangle is 2 root 2. I'm just left to, I want to find this length. That's what I actually want to find. That's the height, essentially, of the trapezium. So what is the base? Well, I'm going to return to that green triangle for a second. We've got a right angle here. We've got G and H here. This is root 2 and this is root 2. So if I know the full length, the full diagonal is 4, which means half the diagonal is 2. So if I can work out this green length that I'm now highlighting here, I can just do 2 minus that, and that will give me the purple bit at the bottom. Now, what do I know? I know I've got a right angle here, but actually I know that the whole thing away along is 2, so this is going to be 1. And something I also know is that this is 90, this is splitting it into 2, so I've actually got an isosceles triangle, which means that length there is also 1. You could use trigonometry, you could use Pythagoras, root 2 all squared minus 1 squared will also give 1, but I can get it even quicker just using the fact that it's isosceles. So that length is 1. Remember, half the diagonal is 2, which means that length is also 1. And we've got a 2 root 2 here. So there it is written in profile form. And question mark is going to be 2 root 2 squared plus 1 squared, all square rooted. 2 root 2 squared is 4 times 2, it's 8. 8 plus 1 squared is, well, 9. So I get root 9. And therefore I get 3. Really nice that we get, because of the dimensions of the cube being surds, we actually get these really nice numbers for the rest of it. So I've got my trapezium, a half times the top, which is 2, plus the base, which was 4, multiplied by the height. A half of 6 is 3. 3 times 3 gives us our answer of 9. So there's other ways to get I think this is definitely the best way to get the the top and top and the bottom for sure. There's other ways to think about getting the height. If you don't like what I did, you could draw it coming down like this and imagine splitting it into two. I think the answers do this and sort of start working out some of these other lengths. In any case, however you do it, you should get 3, and from there the answer comes out. Well done.